In this video, we're going to be talking about the autocorrelation function, ACF, and the partial autocorrelation function, PACF, and most importantly, the big differences between them. So honestly, when I first started learning time series in economics, this was a really big challenge for me, just understanding the intuition behind ACF versus PACF, understanding real-world examples where they both arise, and just understanding how to derive them both mathematically. So I'm hoping to make some of those challenges a little bit easier for you guys. So to start off with, we're going to go ahead and just use a toy example instead of going into a bunch of math theory in the beginning. So what we're trying to do is predict the average monthly price of salmon, maybe in our city. So here's salmon, and we want to predict what is the average monthly price going to be this month compared to last month or the month before and all the months prior. Okay? So here's a bit of notation just outlining that. S sub t is going to be the average price of salmon this month. S sub t minus 1 is the average price of salmon last month. Notice it's just minus 1, so it's the month prior. Okay? And S sub t minus 2 is the average price of salmon 2 months prior. And of course we can keep going. We can do S sub t minus 3, minus 4, and however far we want it. But for the purposes of this video, we're going to stick to just these three. Now a big concept in time series, maybe one of the most important concepts, is that the measurement of some value at a time period depends on the measurement of that value at the previous time period, at the time period before that one, and on and on and on in the past. And that makes a lot of sense, right? Because there's a lot of things that could affect the price of salmon, such as the weather, maybe fishing regulations and stuff like that. But arguably, the most intuitive determiner of the price of salmon this month is just, hey, what was the price of salmon last month? If it was high last month, maybe we expect it to be high this month. If it was high 1 year ago, maybe expect it to be again high this year, for example. So that's the idea behind time series, one of the big concepts in time series, and we'll get more into that a lot in future videos. But for the purposes here, we just need to fill in some blanks in this kind of causal diagram. So here we have three boxes. We have the price of salmon this month, price of salmon last month, and the price of salmon 2 months ago. Now let's just draw a couple of very intuitive arrows that tell us what's going to be correlated with what might cause what. So the price of salmon 2 months ago, and to just make it even more concrete, let's just say 2 months ago was January, then February was last month, and we're currently in March, okay? So the price of salmon in January is definitely going to have some kind of effect on the price of salmon in February. So we denote that by this arrow leading from January to February. Similarly, the price of salmon in February will have an effect on the price of salmon in March. Now there's one more arrow we can draw here, and it might seem weird to draw at first, but it does make sense. The price of salmon in January has an effect on the price of salmon in March through February, right? Because we have an arrow going to February and an arrow going through March. So there is some indirect effect of the price of salmon from January affecting the price of salmon in March. But there's also going to be possibly a direct effect. That's where we skip over the February altogether and just say that there's some kind of mechanism going on here where the price of salmon in January directly affects the price of salmon in March. And to make it more abstract for a second, where the price of salmon 2 months prior affects the price of salmon today. And why might that happen? To give a real world example so it's not just abstract, maybe there's some big food festival that happens in your city every 2 months. So that food festival happens in January, March, May, and on every other month, right? And of course, during that food festival, price of salmon might change because maybe the city wants to make more money off of the big festivities and stuff like that. So the price of salmon in January might directly affect the price of salmon in March because the food festival happened only in both those months, okay? There's a concrete example. There's several others you can think of. Now let's get into the actual meat of this video is first, how do we calculate the autocorrelation function? So I want to know the autocorrelation function, and this, I've written CORR as correlation, but this is the same thing as ACF, autocorrelation function. I want to find the autocorrelation between the price of salmon in January and the price of salmon in March. So that is S sub t minus 2, S sub t, okay? How would I find that? Well, I can find it really easily mathematically by basically just taking, lining up all the prices from 2 months ago and finding the correlation. Here we're talking about the regular Pearson correlation you might have learned in high school or college. and just finding the correlation that way. So for example, going further in time, I could take the price in January and March, and then I would have February and April, then I would have March and May, and so on. And I would just find the correlation between all these different data points, treating this as my X variable, this as my Y variable, and I think you guys know how to find the correlation between two data sets, just like that, okay? But kind of at a more theoretical level, and this is gonna help us understand PACF a lot better. Let me switch over here to a different color. This correlation between January and March, or more abstractly, between the price of salmon 2 months ago and the price of salmon in a current month, is going to be made up of two pieces. And we can see that very easily graphically in these boxes we've drawn here. Because the arrows leading from 2 months ago to the current month, there's two ways to get there. I can get there directly, so one effect is going to come from doing st minus 2 directly to s sub t, right? So that's the direct arrow. And of course, there's the indirect route. So here's the direct route. Of course, the indirect route is s sub t minus 2 going to s sub t minus 1 going to s sub t. So hopefully you guys can see that. So the direct route is going from 2 months ago to the current month, and the indirect route is going from 2 months ago to last month to the current month. And both of these together kind of form the ACF, the autocorrelation between the price of salmon 2 months ago and the current month. Now, how does that contrast with PACF, or the partial autocorrelation? You might already see where this is going. Let me switch sheets here. For PACF, we only care about the direct effect. We don't care about the effect as it comes through other time periods. So we only care about the effect s sub t minus 2 going to s sub t. And why might we only care about that? Why would we sometimes care about ACF and sometimes care about PACF? Well, ACF tells you the correlation between the price of salmon a number of periods ago and the price of salmon today. But of course, there's a lot of different components of that. There's the component directly and there's a component indirectly. Now, we might only care about the component directly because we want to see whether the price of salmon 2 periods ago, so 2 months ago, is a good predictor of the price of salmon today. Based on ACF, it might seem like a good predictor, like if that correlation, remember that Pearson correlation is really high, but that correlation might be high only because of these indirect effects. It might be the case that the direct effect has little to no correlation, will barely help us at all with predicting the price of salmon today. That's why PACF is very, very important, because PACF tells us, okay, taking all those indirect effects away, just getting rid of them, what is the direct effect of the price of salmon some number of periods ago and the price of salmon today? So that's what PACF is. So PACF is direct effect, ACF includes direct effect and all the indirect effects through the intermediary time periods. So now the last thing we'll do in this video is how would I find PACF? Of course, it's pretty easy to find ACF. You literally just do a Pearson correlation lining up your data set, the first column of which is 2 months ago or however many months ago, and the second column of which is today. That's pretty easy, right? PACF seems a little bit more challenging, right? So here's a way to find PACF. You would write a regression model. Let's say we're trying to find PACF of 2, right? So where k equals 2, k being our lag. So you can substitute whatever k value you want. So here we're going to write a regression function where the price of salmon today, which is this, is equal to some coefficient, phi 2 sub 1, some coefficient, times the price of salmon last month, plus some other coefficient times the price of salmon 2 months ago. And of course we have our error term. And now this coefficient right here, this phi 2 sub 2, is going to give us the direct effect of the price of salmon 2 months ago on the price of salmon today. And why is it the direct effect? Why is there no more confounding going on with this intermediary s sub t minus 1? Because we already took that into effect in our model. Because we have a term here which already captures that effect. Therefore, this phi 2, 2 is going to give us that direct effect of price of salmon 2 months ago on price of salmon today. So it is exactly this phi 2, 2, which is the PACF. That is the PACF for k equals 2. If I want to find the PACF for k equals 3, I need to build a new model where I include another term with s sub t minus 3, and the coefficient of that term in the regression is going to be my PACF for k equals 3, and so on, okay? So the last thing I want to do is draw a plot of PACF. We'll be looking at more of these plots in the future as we do more time series type videos. But let's say we find the PACF for k equals 1, 2, 3, 4, 5, 6, 7, on and on and on. And of course these are called our lags. And let's say this is the plot we get. Of course PACF can be negative, right? Because if the price of salmon today negatively impacts the price of salmon, the price of salmon 2 months ago negatively impacts the price of salmon today, then it should be negative. These red bars I've drawn here are error bands. You'll see this a lot going forward. Basically, you can think of it right now as anything within the error bands, so from 0 going out to the error bands, is no different than 0. We don't have any evidence to say that it's actually different from 0. Okay, so think statistical significance. So we see that lag 1 has a non-zero PACF, lag 2 has a non-zero PACF, so it is 3, 4, and 5. But 6 and 7, there's not really any correlation between the 6 months ago price of salmon and the 7 months ago price of salmon, and imagine all future lags and the price of salmon today. So what could a good model look like here? Remember what PACF tells us. PACF tells us the coefficient of the price of salmon that many months ago on the price of salmon today. And if that coefficient is different from 0, as indicated by it being outside these red error bands, then it's a good factor into a model because it can help us make that prediction. So, for example here, this model might look like price of salmon today is going to be equal to, and I'll switch to betas here, so beta naught plus beta 1 times price of salmon minus 1, so month ago, price of salmon 2 months ago, and then we keep going for 3, 4, and 5 months ago, okay? So I won't draw out all of them, I'll draw the last one. Will be beta sub 5, s sub t minus 5, plus, of course, we need our error term. So a good model here might look like coefficient plus all these other coefficients, each times the price of salmon from 1 month ago, 2 months ago, all the way to 5 months ago, because that's what the PACF plot tells us. So the PACF plot is super powerful in helping us identify a good time series model to predict the price of salmon today based on price of salmon in some number of past periods. Okay? So that is a PACF plot. Of course, you might be wondering, why didn't we draw an ACF plot? That is also useful for a different type of model. We'll get there in the future. So just as a kind of teaser, this type of model we've drawn here, where you predict the price, you predict something based on past values of that thing, is called an AR or autoregressive model. Autoregressive because it's a regression, auto because it's based on values of itself in the past. Okay? So that, I hope, was a good clarification for you all in what is the fundamental difference between the autocorrelation and partial autocorrelation, and also how to find the autocorrelation through the Pearson just regular method, and how to find partial autocorrelation by taking a regression and figuring out the coefficient of that term. Okay, so until next time.